section 5.6. We're going to go back, take a little walk down memory lane through our pre-calculus class once again. And one of the things that we're going to find after doing all these inverse functions in the first part of this chapter is now we're going to reintroduce trigonometry. So what we have, so first goal is we're going to go back and we're going to look at inverse trig functions. And then we're going to try to rewrite some of these trig functions in algebraic form. So first thing that we've got going on here, so inverse trig functions, just a little bit of a reminder as we're looking at inverse trig functions. Sine inverse of x, another way to write this would be arc sine of x, and I want you to get used to both of those notations because sometimes they'll be written one way depending on the author, depending on what it is that you're looking at. They may use either notation, so just remember the inverse sine, and this is not sine to the negative 1 power, that is inverse of the sine function. And this also means the inverse of the sine function. So what we have going on here, I've got a little more than one period of a sine function drawn. But remember from what we learned about inverses, inverses have to be one, or in order to have an inverse of function, it has to be 1-to-1. Well, that sine function that I'm looking at and the cosine function next to it, neither of those are 1-to-1. So what we have to do is we have to limit the domain. So hopefully you'll remember from your days in pre-calculus that we are going to limit the domain for sine. If you look at what's inside that red box, that is definitely a 1-to-1 function. And so what that means is if I'm looking for sine inverse of a negative number, I'm going to be looking, let's see, so here, this is quadrant 4 if you were looking at the unit circle, between negative 90 or negative pi over 2 radians and 0 radians. And then this is quadrant 1 right there in between 0 and pi over 2 radians. So if I'm looking for sine inverse of a negative number, my answer is going to come from quadrant 4. If I'm looking for sine inverse of a positive number, my answer is going to come from quadrant number 1. So we're limiting the domain. We want a 1-to-1 function that is a continuous function, and everything, because everybody's positive in quadrant 1, we want to use that. And then in order to have a continuous function, we also use quadrant 4. With cosine, if we do the same thing, now we don't want quadrants 4 and 1 this time because we wouldn't have any negative y values. So this time we're going to limit the domain for cosine to go from 0 to pi. So what we have, this 0 to pi over 2 radians would be quadrant 1, pi over 2 to pi radians would be quadrant number 2. So when we look at arc cosine or cosine inverse of a, cosine inverse of a negative number is going to put us in, cosine inverse of a negative is going to put us in quadrant number 2. Cosine inverse of a positive number is going to put us in quadrant number 1. So and we're working on those, so quadrant 1, quadrant 2 for cosine, and then cosecant and secant, these are going to match. So cosecant inverse, this is going to match sine. Okay, we're going to do exactly what we did for cosecant inverse, exactly the same way. So we're looking at quadrants 1 and 4 for our cosecant inverse, and secant inverse is going to match cosine. So we're looking at quadrant number 1 and quadrant number 2 for our potential values. The ones that are going to throw you off a little bit are your tangent and your cotangent. So I've got more than one period of tangent drawn here. And notice with tangent, remember its period is half that of sine and cosine. So when we look at tangent, and granted my tangent graph should have an arrow here and here, and it's got an asymptote at pi over 2, and it's got an asymptote at negative pi over 2. So when I go and I look at that graph, that's what we're going to do. We're going to limit our domain for tangent to be in between negative pi over 2 and pi over 2. So again, we're looking at quadrants. This is quadrant number 4 for tangent. This is quadrant number 1. So tangent inverse of a negative is going to put us in quadrant number 4. Tangent inverse of a positive is going to put our answer in quadrant number 1. And when we look at cotangent, it would be nice if it worked the same way. I mean, when you look back up here above, whatever happened with sine, we also went with its reciprocal function cosecant. Whatever happened with cosine, we also used its reciprocal function secant. tangent and cotangent may be reciprocals, but their inverse functions don't work the same way. And the reason they don't work the same way is if you look at these graphs, now we have asymptotes here at 0 and at pi instead of at the multiples of pi over 2. So when we look this time and we limit the domain for cotangent, this is the one that you're going to want to put a little star by because this one the rules change a little bit on. Cotangent inverse of a negative number, and again I guess it looks like I'm missing my arrows on the end of my graph. But cotangent inverse, let's see, so now we're looking from 0 to pi. So a positive value is going to put us in quadrant 1. A negative value is going to put our answer, whoops, sorry, that's not a 4. How about if I write it properly? That's going to put us in quadrant number 2. So cotangent inverse of a negative value is going to put our answer in quadrant number 2. Cotangent inverse of a positive number is going to put our answer in quadrant number 1. So there's your background on your days from pre-calculus. Hopefully that's not a big surprise. Hopefully that's something that you're relatively comfortable with. Two things you're going to need for every one of these problems. You're going to need to come up with a quadrant, and you're going to need to come up with a reference angle. If you can come up with those two things on every one of these problems, and the problems 1, 2, 3, and 4, you're going to find things to actually be pretty simple. So that's what we want to do. So with that said, arc sine of 1/2. We're talking about finding, so if we wanted to rewrite what we really want to know, this is really asking us the sine of what angle y is equal to 1/2. That's what I really want to know. Well, if I'm trying to work this through, I have a positive value that's given to me right here. If I have a positive value, that means my answer is coming out of quadrant 1, because inverse sine of a positive value is coming from quadrant number 1. Well, then I come over here and I go, all right, well, what reference angle do I have? What y has an opposite of 1 and a hypotenuse of 2? Well, that looks like this y is going to be pi over 6 radians. So if that's pi over 6 radians, combining this information, quadrant number 1, pi over 6 radians, makes for an easy combination this time. But really, those two green arrows are the two pieces that you're trying to bring together every time. What's your quadrant and what's your reference angle that you're trying to use? Second one. So this time we don't have a variable listed in the problem. So if you wanted, you could think about it this way. This is the same thing as the x I'm trying to solve or the y I'm trying to solve, whatever variable you want to assign. So what do I really want to know? I really want to know negative root 3 over 2 is the cosine of what angle x? That's what I'm really trying to sort out. So because we're talking about a negative, whoops, I wanted to move this out of the way. Because we're talking about a negative, as soon as we see this arc cosine of a negative, we know our answer is coming in quadrant number 2. Now once I've got that part figured out, I can effectively ignore the negative the rest of the way. So now what I really have, and I know a lot of my students like to draw reference angles, reference triangles, so they look like they're in the right quadrant. So if I know this, what have I got? Well, the x that I'm trying to find is supposed to have an adjacent of root 3 and a hypotenuse of 2. And a lot of my students will like to put the negative on the root 3. You can do it either way. The truth of the matter is, what's my reference angle? It looks like this time my reference angle, x, is going to end up being pi over 6. Well, now when I put that pi over 6 into quadrant number 2, well, what do I have? Well, then that means I'm going to be pi over 6 radians shy of getting all the way to pi, or to 180 degrees. So that's going to give me an answer of 5 pi over 6 radians. So quadrant number 2 with the reference angle pi over 6. Problem 3. Now it's a little bit more complex, because what you've got going this time is you've got some stuff nested inside of things. So what I'm ultimately trying to find here, what I'm going to recommend to my students every chance they get, is always start a problem like this off by calling what's inside this quantity theta. Now, if you rewrite your equation, what I really have is theta is the same thing as arctangent, or tangent inverse, of 3/4. Now let's solve for theta. Let's figure out what we've got going. Well, what I really want to know is the tangent of what angle theta is 3/4. Well, that's going to have, let's see, we're in quadrant number 1 because tangent inverse is being expected to be positive. Now, I need a reference triangle for tangent of 3/4. So I'm going to throw in my theta and my 3/4. So my opposite is going to be my 3, my adjacent is going to be my 4, and that means I know my hypotenuse is going to be 5. Okay, well, I guess without a calculator it's going to be a little bit of a challenge for me to figure out what theta is. But here's what's nice. what do I really want to know in this problem? I really want to find the sine of my theta. Well, is that theta the same as the theta I made in my reference triangle? It absolutely is. So what would be the sine? Well, use the sine ratio. The opposite side is 3. The hypotenuse is 5. It looks like what we're going with right here is 3/5. So again, the quadrant is important because I need to know what quadrant I'm working from. But once I've got that reference triangle, that blue reference triangle down there, everything kind of falls into place. So if we do the same thing with number 4, I'm going to start off by saying, here's my theta. This is theta. What do I really want to find in this problem? I really want to find the tangent of that theta. So if I can come up with a reference triangle, I'm golden. So let's rewrite this equation. According to this thing, the arc sine, so theta is the same thing as arc sine of -5/6. So that must mean, what I really want to know is the sine of what angle theta is -5/6. Well, sine inverse of a negative number is going to put our answer in quadrant number, let's see, sine, arc sine, go back and look if we wanted to. That's going to put us in quadrant number 4. So we know our answer is coming from quadrant 4. So as soon as I know that tangent in quadrant 4 is going to be negative. So my answer to this whole problem had better end up to be a negative number. So now I need a reference triangle. So reference triangle, I'm going to put my theta on here. Let's see what we got going. So here's theta, and my opposite side is supposed to be 5, and my hypotenuse is supposed to be 6. 6 squared is 36, 5 squared is 25, 36 minus 25 would be 11. This third side is root of 11. So there's my reference triangle. Remember, we're talking about this reference triangle with quadrant number 4. So the tangent is going to end up being, well, let's see. So the tangent to this let's not make that look like a negative sign. The tangent to this thing, let's see. So I'm looking at the opposite over the hypotenuse of our theta, and I want to put it in quadrant number 4. So quadrant number 4, maybe I should redraw my triangle. Maybe that would make some people happier. So let's say that I did this. Okay, if I redrew this triangle so it looked like it was in quadrant number 4, then what a lot of students will say is, okay, so here's what theta is. It's in quadrant number 4. My opposite side is a -5 because it's going downward in quadrant number 4. My hypotenuse is a 6. Now we're still going to end up with this root 11, but if we're in quadrant 4, the horizontal distance is positive, the vertical distance is thought of as being negative. So now if I go to find the tangent, my opposite side is -5. My adjacent side is my root of 11. I'm going to end up with -5 over root 11 for the tangent of theta. So as you're working through some of those, sometimes we'll have some difficulties with them. But once you've got those two things that I have listed up here on the top of the page, once you've got a quadrant and a reference angle, pretty much everything else will take care of itself. So, all right, last two, write these in algebraic form. So the second goal of the day is being able to take these trig expressions and write them in algebraic form. So I've got secant of arctangent of 3x. So let's do the same thing again. I'm going to start off with this being theta. So what I'm really looking for is the secant of this theta. That's what I ultimately want. So my theta says theta is the same thing as arctangent of 3x. So what I really know is the tangent of theta is supposed to be 3x. Now, we don't know if x is positive, if x is negative. We don't know. So we're going to have to limit ourselves on the quadrant right now. But we do have the capability of creating a reference triangle. And that reference triangle has my theta right here. But now, let's see, tangent would be opposite over adjacent. So my opposite side is that 3x, and my adjacent side is a 1. We'll now do a little Pythagorean theorem. 3x being squared would be 9x squared. 1 squared would be 1. Add those two things together and put it underneath the square root for Pythagorean theorem. That's the root of the quantity 9x squared plus 1. So there's my reference triangle. We said the quadrant we couldn't do anything with because we've got variables now. Do we have the capability of finding the secant of theta? Well, the cosine of theta would be 1 over the root of the quantity 9x squared plus 1. We don't want the cosine. We want the reciprocal of that cosine. So we're looking at the root of 9x squared plus 1, technically divided by a 1, but you're probably not going to write it that way. So root of 9x squared plus 1. So again, the key, quadrant, reference angle. If you can't figure out the quadrant, the reference angle is going to take you wherever you want to go. All right, last problem, number 6. We're going to look at it the same way. Now, I've got arc sine on one side. I've got arc cosine on the other side. We've got a lot of crazy stuff going on right here. So what if we do this? Let's say if I ultimately want to find probably an expression that's going to find us a way to help solve this thing, let's start by doing this. Let's say that I'm going to move either the arc cosine or the arc sine. I'm feeling like let's start by moving the arc cosine. If we do that, this y in the equation would be the same thing as the cosine of the quantity arc sine of the quantity root of 36 minus x squared over 6. And if you look at what we have right there, what we just did effectively is we turned the left side of this thing into problem number 5, which is right next to it. So we're gonna handle this exactly the same way. We're going to do a little theta substitution, and I hope I've got enough room, but I might need to zoom this a little bit. So zoom this in a little bit so I got a little more space. So we're going to do this theta substitution. Let's call this thing theta. So what am I ultimately looking for? I'm looking for y to be equal to whatever the cosine of our theta is. That's what I ultimately want to know. Once I find what that cosine is, we'll plug it in and we'll have an equation that we'll have for y. So now let's see. So let's rewrite our theta. So according to this, so theta would be arc sine of that quantity. So what we really have is the sine of theta is equal to the root of 36 minus x squared over 6. Well, can we make a triangle? Sure we can. According to that, the theta that we're dealing with, well, the opposite would be that root, 36 minus x squared. The hypotenuse would be a 6. Now, finding this last side is going to be a bit of a challenge. I'm actually going to write this down this time. So let's see. So this 6 squared minus the quantity root of 36 minus x squared being squared. And if I put all that underneath the square root, I'd have what this third side is. So this looks like, let's see, what do we have here? So this is a 36 minus a 36 plus an x squared. 36's drop out. What I really have is a square x squared. Looks like this third side is ultimately going to end up to be just a plain old ordinary boring x. So now what was I looking for? I was looking for the cosine of theta. So there's theta. There's my reference triangle. The adjacent side is x. The hypotenuse is 6. Looks like y is equal to x over 6. So what I did is I effectively rewrote that thing, cleaned it up, and that's kind of some expressions with our trig stuff.